whatever, I don't know. Then I'm gonna go to like infinity of some kind. So the only thing, when you look at a problem and you see number on top, 0 on bottom, you know it's gonna go to infinity, plus or minus. It depends on like the direction of stuff here. Maybe I'll even stick in one more. But let's see. So this top one, I've got 0 on bottom. I'm approaching infinity, positive or negative infinity. So what happens as x is approaching 0 from the right? What kind of numbers are those? Those are positive, right? This is x is bigger than 0. So these are positive. So this thing is positive but approaching infinity. What about these bottom ones? What's different about how we're approaching 0?
You're approaching from the left side, so it goes in.
Okay, so these ones I'm approaching from the left side.
Except for that one.
And what's the difference between 1 over x to the 5th and 1 over x squared?
So if you have a square, it tends to be positive.
When we square negative numbers, they become positive. So this one would be positive infinity. This one would be negative. Any questions about any of these ones? So most of the other versions of this problem, they might not be approaching 0 in the limit, but all the other ones are like, oh, I'm going to have x approach 2 and then I've got x minus 2 over here. As long as you look at it and you see a 0 in that bottom, you know it's infinite and you just have to figure out the sign. As long as you see an infinity in the bottom and a number on top, you know it's going to 0. And that's like almost maybe half of the limits that you're going to see in Calc 2 are going to be of this form, where it's either approaching infinity on bottom or 0 on bottom and a number on top. So if you can talk yourself through any of these, you're going to be in really good shape. Okay, questions? All right, so for the last like 20 minutes or whatever before we go to lunch, I know we've been doing all these infinite limits, and we write like infinity, and we say this limit is going to infinity, and in Calc 2 you're going to do kind of a lot of explorations about infinity. So I want you to turn to a neighbor and just kind of like, I don't know, talk about infinity for 5 minutes. Like seriously, what is infinity, and why do I keep shouting at you guys that infinity is not a number? And like, you know, what intuition do you have about what infinity means? Yeah, so just like talk for a couple minutes, and then we'll chat as a group, and we'll maybe do some kind of explorations with infinity. words or thoughts. So I'm going to start with yours. You said an idea.
Yeah.
It's
So
an
I feel
idea.
like infinity is the idea that there is more. Something like that.
Okay. This idea like there is more than one.
Then what we know,
Yeah.
or what's in our capacity.
Okay, so it's like this. I heard maybe were you guys back there saying something about like it keeps going.
Yeah.
Like, okay, so there's more, or like, it keeps going. Or, when we talk about, infinity just specifically, like, okay, in math, and I say something is infinite. So like, okay, what's the opposite of us saying something is infinite?
Nothing.
It's finite. Okay, so I've got like maybe this idea of like finite versus infinite. So if I told you that something was finite size, that means it's like there's an actual number that we could give to describe it. Like if I told you, like the area of this room is finite, there's a number that we could use to describe it. If we say something is infinite, what are we saying then? That there's no end, it's not finite, there is no number we could use to describe it. So what you might be thinking about when you're thinking about something that's infinite is this idea that you are choosing you're choosing a quantity or a concept that is bigger than all of the numbers. So bigger than all numbers. Okay? So let's just start off, like, when we talk about numbers, I know a lot of times we talk about different kinds of numbers. Like there's whole numbers, there's fractions, there's real numbers. Let's just start with whole numbers for a second. So like 1, 2, 3, 4. So what's a number bigger than 4? 5. What's a number a lot bigger than 5? 1,000, 5,000. What's a number bigger than 5,000? Okay, so 26,000 maybe, I don't know. So if we were going to play a game where we were going to take turns and say a number bigger than the person before, would there be a winner?
No.
Okay, no. So what this is saying to us, this infinity, I know you like want to say like, oh, the trump card is infinity. But it's not quite a number. So this idea of like, I cannot tell you the biggest number, there is no biggest number, this is the concept of infinity, okay? So, I just wanted to kind of like, I don't know, nail down this idea that when we're talking about infinity, we are talking about a quantity that is bigger than all other numbers that we could name. And so, the point is that it is this concept, not a number, and it is weird. So something that you guys are going to see a lot in Calc 2 is that weird things happen when you consider infinity. And I think we've kind of already seen it. Well, I erased this, but okay, this is weird. It is weird that you put polynomial over polynomial, and sometimes you get a finite number, sometimes you get 0, sometimes you get infinity. Infinity is weird. It doesn't behave in kind of a predictable way, and so strange things can happen. So, let's play a game. Just to kind of, I don't know, illustrate that you can use infinity in kind of strange ways. So let's say we have a hotel, and let's just start off with this. Let's say our hotel has 100 rooms. And they're all occupied. So there is a person staying in every one of the 100 rooms. What happens when one more person shows up? Can you find a room for them in this hotel?
No.
No, there just is no space. What would you have to do? You'd have to like kick somebody out of their room if you wanted to get that person. A room where you'd have to show them away. Okay. And it doesn't matter if I picked 100 or 5 or 1,000,000. So now let's say we have a hotel, and it has infinitely many rooms. I know this is like maybe uncomfortable because you're like, well, you can't build this hotel, but this is a thought exercise. Okay, so you've got this hotel with infinitely many rooms, and there's one person in each room. So all we're saying here is like, no matter which room, there's infinitely many, but no matter which room I pick, I'm like, who's staying in room 17,628? I don't know, a person is staying there. Now, one more person shows up. Talk with your partner, can you find them a room? Just talk, how would you do this? And I'll put up a couple more for you to think about. The infinitely many rooms are all occupied.
Oh, they're all.
So like any room I pick, room A, room B, room whatever, you can number them, room 1,713. So yeah, so how does this work? And if you think you know, maybe try like, well, what if two people show up?
Yeah.
Yeah, okay, and they're not gonna share a room. Okay. Or
The owner of this hotel, I just wanna know, are anything, got 100 rooms filled up?
yes, there is one person in each room, and that's it. Only one person can stay in each room. No, I know. This is like it's.
He's still living.
Go away.
So they're all packed. Those are people like, they had to make a room because you didn't, they had to make a room that's next.
Ours are really infinitely room if they can't fit on Harvard, so that's like.
Okay. Oh, this is actually a good question.
Not
Lauren.
even utilized.
So are there really infinitely many rooms if we're gonna end up saying that we can't fit another person?
Yeah.
That's what you're really. That's like a key insight.
So you said no matter what, are there infinitely people?
Well, so if we're saying there's one person in each room, I guess we're saying there are infinitely many people in this staying in this hotel. So I don't know. So are we leaning towards yes, there's room for this one more person, or no, there's not room?
Yeah, there's still room.
So we think there's still room, and I think so. Like Valerie was saying this thing of, well, if we couldn't find a room for them, then are we really saying there's infinitely many things, or are we kind of saying like there's only finitely many and they're stuck in those rooms? So what are you thinking, Dylan?
If there's really infinitely many rooms, then there would always be room for one more person.
Okay, because infinity is this idea that like there's always more, it always keeps going. Okay, so there should always be room for one more. Do we feel like maybe that seems reasonable? There should be room for one more. But is our problem right now like, but how?
Yeah.
Okay, good. These are really good questions. There should be room for one more, but how do we make room for one more?
But then there's always been room for them. That's the thing. With like infinity, like I'm sorry.
Yeah, no. Okay, so there was room for them, but how do we like turn it into an idea that we feel comfortable saying, here's how we make room for them?
What if you put them into like first room and tell them where to move down?
Oh, this is a great
I
idea,
love that.
Pedro. Okay, so the one more person shows up, and we're gonna give them room 1. But there was a person in room 1, so where are we gonna send them, Pedro?
To room 2.
Okay, we're gonna send them to room 2. Okay, but then where are we gonna send the person in room 2? They're gonna go to room 3, and then where's the person in room 3 gonna go? Okay, they're gonna go to room 4, and now are we ever gonna run into a problem where we've run out of rooms to do this? No. So this is where the idea of infinity, where you were like, oh man, but they were all full. we just can shift everybody down. Because what happens when we add 1 to each thing? We're just going to the next number, but are we gonna run out of numbers?
No.
We're never gonna run out of numbers. Okay, so what do we think we're gonna do if 2 people show up? So where are we gonna put our first 2 people?
Everybody moves to
One will go to 3, 2 will go to 4.
Okay, so we'll like stick our 2 people in these rooms, and then we send the person from room 1 to room 3. And where's the person from room 2 gonna go?
4.
So 4. Where's room 3 person gonna go?
5.
So 5. And where's room 4 person gonna go?
7.
To 6. Yeah, okay, and then can we keep doing this?
Yeah.
Even though it's like an additional 1 than this?
Well, it's like a plus 2, so it's like a series.
So we're just saying like send the person in room N to room N plus 1. Or sorry, N plus 2. Okay, so like if 3 people showed up, do we think we could find room for all 3 of them?
Yeah.
If 4 people showed up? If 100 people showed up?
Everyone's can read that.
Okay, so now, what I will give you to ponder on your lunch break, if you so choose, is what happens if infinitely many people show up? Can we make room for them?
Yes.
We feel like maybe we can, but how? Think about it, and I will have the punchline for you guys when we come back. Or maybe you will have the punchline for me when we come back.
Are one of you guys sure? Did you for sure? Are you for sure? Okay. You can always be right. Right. Sorry. That was good though.